Hello friends, welcome again in Gate architecture videos. So today we will discuss about the numericals of Gate exam. So first we will discuss about the acoustic questions. So for acoustic, we start with intensity level. Intensity level in decibel, L is equal to 10 log 10 I over I naught. I naught is equal to base intensity here and I is equal to intensity. Threshold of hearing is equal to 0. We take a 0 at intensity level of 0. So if we take an example, if intensity increases 100 times its original intensity, then change in intensity level. So this type of question is asked in previous GATE exam. If intensity increases 100 times its original intensity, so we have formula and we put the value of changed intensity which is 100 times which is 100 times bigger or increased 100 times. So we put L is equal to 10 log 10 I over I naught. Okay, so the value of I, we put the value of I here, I naught 100, and then this becomes the 20 decibel. So if we know the formula, we can solve the questions. Then the inverse square law is there. If distance between sound source and receiving part doubles, the sound will get 6 decibel lower. So these are the concept we should know. And if distance become half the sound, will get louder by 6 decibel. Distance अगर कम होती है, half हो जाती है, तो sound will get louder by 6 decibel. और distance अगर increase हो जाती है, तो sound will get 6 decibel lower. And this is also asked in GATE exam previous. Then we use the Sevin's formula RT60, reverberation time is equal to 0.161 V over total absorption in Sevin's. So this is the formula we will use in numericals. And here this is a total absorption in Sevin's. So in a room there will be more surfaces and the surface absorption coefficient will be given. So we will calculate the absorption coefficient and area, and then we will find out the total absorption in Sevin's. Now Sevin's, the unit is square meter. Absorption coefficient range is between 0 to 1. So absorption coefficient 0 से 1 के बीच में होता है, and 0 is for when sound is not absorbed, and absorption coefficient 0 is used when sound is not absorbed, and 1 is for 100% sound absorption conditions. So absorption coefficient की जो range होती है 0 से 1 के बीच में होती है. Okay, तो 0 से 1 के बीच में अगर आपको एब्जॉर्प्शन कोएफिशिएंट नहीं दिया है तो हम उसको एज्यूम भी कर लेते हैं कभी. सो टोटल एब्जॉर्प्शंस इन सेविंस जो होता है टोटल एरिया इनटू एब्जॉर्प्शन कोएफिशिएंट, टोटल एरिया इनटू एब्जॉर्प्शन कोएफिशिएंट. एंड वी आल्सो स्टडी नॉइज क्राइटेरिया एनसी, साउंड ट्रांसमिशन क्लास एसटीसी. ओके, construction materials have an STC rating. This STC rating describes how effective the material in transmission behavior. So this is for theory. STC and noise criteria is there, NC, and noise rating value is there. Example: if sound is doubled, then calculate the increase in the acoustic intensity level in decibel. So sound double हो जाती है, we have to calculate the intensity level, and intensity level in decibel is L is equal to 10 log I over I naught. Okay, this is the initial intensity and this is the change one. So let initial intensity level L1 is equal to 10 log I initial over I naught decibel. Then after sound is doubled, L2 is equal to 10 log I2 over I naught decibel. So we take intensity level at 2 stages. Then so change in intensity level is equal to L2 minus L1. So 10 log I2 over I naught minus log I naught over I naught, then 10 log I2 over I1. So here this is I1, mistake. So 10 log I2 over I1. L2 minus L1 is equal to, now because I2 is equal to 2I1, I2 increased intensity is the double. Then we calculate this 10 into 0. log 2 value and L2 minus L1. So basically change in intensity level. So this is the L2, L is denoting here intensity level, and the in decibel. So whenever we are using L and this type of formula, this intensity changes in decibel, sound level. Then if we take an example, a hall of volume 5500 cubic meter is found to have a reverberation time of 2.3 seconds. The sound absorbing surfaces of the hall has an area of 750 square meter. Calculate the average absorption coefficient. So हमें वॉल्यूम दिया हुआ है, रेवोल्यूशन टाइम भी दिया हुआ है, साउंड एब्जॉर्बिंग सरफेस ऑफ द हॉल हैज एन एरिया हमें भी दिया हुआ है हॉल का. अब हमें कैलकुलेट द एवरेज एब्जॉर्प्शन कोफिशिएंट फाइंड आउट करना है. सो लेट सपोज एब्जॉर्प्शन कोफिशिएंट हमारा जो है दैट इज A. So let, and we can say it absorption coefficient is equal to A. Okay, now we know the formula. T is equal to 0.161 V by AS. Okay, now if we calculate we are having the area and we have to find out the absorption coefficient. So we do the formula like this. A is equal to then 0.161 V by T will come here, A will be there, so S into T. Now we will put the value 0.161, volume is given 5500, area is given 750 into आपका revolution time is 2.3. So solving we will get 0.513 answer. So this will be the absorption coefficient. So here this is, you can take this, actually this is the sigma SA. So here absorption coefficient is multiplying with the area of the surface. So this type of question will be solved by this formula. Now if we will have the question like this, what is the resultant sound level when a 70 decibel sound is added to a 80 decibel sound? So we know the formula. L is equal to 10 log we are having the formula. What is the resultant sound level when a 70 decibel sound is added to a 80 decibel sound? There is 70 decibel sound is already there, is 80 decibel sound is already there, and we add the 70 decibel sound. So resultant sound level we have to find out. So formula of sound level is equal to this. Now at the condition of increased sound level of 70 decibel, we can have this. So let's suppose the intensity changed. So 10 log 10 x intensity increased by x for the resultant sound level. So, and this is the 70 decibel sound हमने ऐड किया, तो 70 is equal to 10 log 10 and this will go x. Now 7 is equal to log 10x, ठीक है, इससे हमने इसको काटा, then 7 log 10x. Now x is equal to 10 to the power 7. X is equal to 10 to the power 7. So we can say resultant sound level is increased 10 to the power 7 time of original. So if we know the formula, we can solve the any type of question. So what is the resultant sound level when a 70 decibel sound is added to a 80 decibel sound level? So we find out the what is the sound level and which is we are adding. So 70 is equal to, we put it into the formula 10 log 10x, and this become the so the resultant sound level is increased in the times of original. So our intensity or sound level is increased by 10 to the power 7. So this is the also method to solve the resultant sound level. And we have earlier discussed about the some acoustic formula, and so we will just get a quick notes. Inverse square law, where we know humans can detect just a 3 decibel sound level difference. So anytime, this is the thumb rule, if the sound level is increased in any numbers, just add the 3 decibel, because we can detect only 3 decibel sound level difference. If there is 70, then added 80, so you can add just 3 decibel. Now increase in intensity level, this is the formula we were using. L is equal to 10 log base to 10 final intensity by initial intensity I over I naught initial. So this is the formula we were using. So this is the important, and you can note down this. L is equal to 10 log 10 final intensity by initial intensity. All the calculation will be done by this formula. Then this is also an important formula. P is equal to 10 log I naught. Sometimes we call intensity level as B. So by changing here value, we find this formula. I is equal to I naught 10 to the power B by 10. So this was the for the equation we were solving that time, and after solving we get this intensity I is equal to I naught 10 B by 10, and you can put L in place of B. So this is the also important formula, I is equal to, and sometime we can use this formula, I is equal to proportional to the 1 by r square. So in place of I we use the 1 by r square in formula, and then we get the formula B2 is equal to B1 plus 20 log R1 by R2. This is also the important formula, and we have discussed it earlier. I2 by I1 is equal to I0, and if we take the ratio of this formula, putting the initial and after frequency I2 I1, then we solve by log, we take the log, to taking the log we find out this value as B2 is equal to B1 plus 20 log R1 R2. So this is also the important formula, and you can say like L2 is equal to L1 plus 20 log R1 by R2. Now we will discuss about the lighting questions. So lighting, we will go quickly to the formulas, and we have this also we have discussed earlier. So lighting calculation, illuminance is the total luminous flux per unit area. Illuminance की जब भी बात होगी तो luminous flux per unit area. Concept of utilization factor, UF is equal to FR by FI, and flux received, flux emitted. Then concept of utilization factor say you can calculate the illumination level, E is equal to FR by FA area. Then it becomes this formula, E is equal to FI into UF A, and flux emitted, F is equal to E into A by UF. This is the if utilization factor numericals is there. And lumen method, this is the important, and we will use this formula only. Illumination lux is equal to always total number of luminary into light fixtures rated output. एक light fixture का कितना होता है into utilization factor and maintenance factor by room area, and we can put the value here and we can find different value. So this is also the important formula. And daylight factor, illumination inside in a working plane divided by illumination outside by overcast sky design into 100. So daylight factor is equal to EI. So sometimes the daylight factor question also comes. Daylight factor is equal to EI EO into 100. This formula we have to remember. Then daylight factor is equal to sky component plus external reflected component, then internal reflected component. This formula is also there. So now flux, luminous flux is the measure of brightness of a light source. So flux is measure of brightness. So we will calculate it in a lumen. So unit is lumen. Luminous flux की brightness कितनी है? तो illumination अलग है, flux अलग है. तो flux को brightness हम बोलते हैं. तो luminous flux is the measure of brightness. तो flux क्या हो जाएगा? Illumination required into surface area. अब luminous flux is the measure of brightness of a light source. So brightness कितनी है? तो we have to calculate it by surface area. Surface area में illumination required जो lux पर स्क्वायर मीटर होता है, तो स्क्वायर मीटर आपका स्क्वायर मीटर से यहाँ पे कैंसिल हो जाएगा, तो फ्लक्स आपका निकल जाएगा. फ्लक्स इज इक्वल टू आपका ल्यूमेन में इसकी यूनिट होती है. देन इल्यूमिनेशन, दिस इज ऑल्सो इनवर्स स्क्वायर लॉ फॉर्मूला, E इज इक्वल टू आई डी स्क्वायर कॉस थीटा. सो D इज इक्वल टू डिस्टेंस बिटवीन लैम्प एंड सरफेस, थीटा इज द एंगल. ठीक है, वी विल डू द न्यूमेरिकल बेस्ड ऑन दिस फॉर्मूला ऑल्सो. So whenever there is candela is given, distance is given, angle is given, this formula will be used. E is equal to I by d square cos theta. Now luminous flux contribution to illumination. luminous intensity क्या होता है? luminance per square meter. intensity कितनी है? sometimes it is candela per square meter, luminance per square meter, candela lumen per steradian. So amount of flux in a particular direction per unit solid angle. तो जब भी angle की बात होगी per unit solid angle, that is luminous intensity. Okay, and what is the illuminance? Illuminance is the lux and is the effect of the luminous flux to a surface. luminous flux का effect जो होता है luminous एक surface पे, that is called illuminance. तो we can note down these things and we can compare, then we will remember, because this is a bit confusing topic. luminous flux, luminous intensity and illuminance. Illuminance is lux and the effect of the luminous flux to a surface. Luminous intensity, amount of flux. Effect of luminous flux, amount of the luminous flux, contribution to illumination. So we have done this inverse square law, d distance, then E is equal to I d square, inverse square law, and if the cos theta is involved, then this will go like this theta, and this will be the distance, and applying, we calculate this first, then we put the value I d square, and if the incident rays is like this, then we add the cos theta, this cos theta. So this is the actual formula. E is equal to I d square cos theta. Luminous efficiency is the ratio of the luminous flux emitted by a lamp to the power it consumed. Unit lumen per watt. This is also important. Luminous efficiency is the ratio of the luminous flux emitted by a lamp to the power. Okay, lumen per watt, lumen to the power. And lumen method, illumination is equal to, so this is the formula, lumen method. Illumination is equal to N into F, UF, LLF and A. So LLF maintenance factor is, we can say this light loss factor, maintenance factor. N is equal to number of luminaire, sometimes number of luminary, and in a big luminary there is number of small luminary, like in a false ceiling in a showroom. So this is also there. So sometimes the tricky question will be there. E is equal to then N into N. Number of luminary 1 and number of inside luminaries, lamp, so N into N. So basically it is only N. So E is equal to, and F is equal to flux, utilization factor, and maintenance factor, light loss factor, divided by A. So this is the formula for calculating the number of luminary and calculating the illumination required, or illumination in a room. So we will use this formula also. So this is candela. It measures the amount of light emitted in the range of 3-dimensional or angle per angular plane. So candela की जब भी बात होगी, ये amount of light emitted in the range of a 3-dimensional. तो candela इंटेंसिटी कितनी है, वो 3-dimensional. लक्स मेजर ऑफ इल्यूमिनेशन ऑफ अ सरफेस, नॉट एंगल. लक्स की जब भी बात होती है तो वो सरफेस के लिए होती है, इस सरफेस में या रूम एरिया में, ओनली रूम एरिया, इसमें एंगल इन्वॉल्व नहीं होता लक्स में. लुमिनेंस इज अ मेजर ऑफ लाइट एमिटेड फ्रॉम अ सरफेस. लुमिनेंस क्या है? सरफेस से लाइट क्या एमिटेड इज ए मेजर ऑफ लाइट एमिटेड फ्रॉम अ सरफेस। इल्यूमिनेशन और फ्लक्स होने के बाद किसी ऑब्जेक्ट से लुमिनेंस, इसकी चमक क्या है, तो इज ए मेजर ऑफ लाइट एमिटेड फ्रॉम अ सरफेस। सरफेस की चमक क्या है, दैट इज द लुमिनेंस। So we will calculate some numerical. So if illumination is given like E is equal to 300 lux, 300 lumen per square meter, efficiency is equal to 60 lumen per watt. Okay, we have to calculate the light power density. Light power density, LPD, light power density or light power is equal to illumination by efficiency. Okay, watt per square meter is the unit, and we solve this 300 lumen divided by 60, then we get the 5 watt. And this is the GATE 2019 questions. Again, question from GATE 2017. Find the lux at a distance of 3 meter from the light source. The light source has power of 40 watt and efficiency of 40 lumen. So luminous efficiency, this time we have to calculate the efficiency. Luminous efficiency is equal to lumen per lumen divided by power in watt. So lumen is equal to 40 into 40 is equal to 1600 आपका lumen आया है यहाँ पे. So basically we have to find the lux at a distance of 3 meter from the light source. Light source से 3 meter की distance पे हमने how much is the lux involved. तो अब डिस्टेंस हो गई है यहाँ पे वर्किंग प्लेन पे. तो फर्स्ट वी हैव कैलकुलेटेड द luminous efficiency. Luminous efficiency is given. We found the lumen. Now we know the lumen, like illumination level कितना है lumen per. So we found the lumen, and for calculating lux we apply inverse square law, which says the intensity of illumination in proportional to the inverse square of the distance from the light source. So light source की जो distance दी हुई होगी उसको हमने square करना है, and lux is equal to होगा lumen of light source कितना है उसको divide करना है distance के square से, तो हमारा lux calculate होगा. And lux is also per square meter of surface area, so that become the lumen per square meter. Here this becomes a lumen per square meter. Okay, and lumen per square meter is the lux. किसी एक पर्टिकुलर पर स्क्वायर मीटर में आपका लक्स कितना है, और लाइट सोर्स का lumen ऑफ लाइट सोर्स 1600 है. So this is the important one. So GATE 2018 question. The indoor illumination required for a building is 350 lux. Indoor कितना चाहिए 350 lux. If the daylight factor is इतना and the design sky illumination already जो illumination है 9000 lux है, then the required supplementary artificial lighting. Required supplementary artificial lighting मतलब अभी हमें कितने की और ज़रूरत है. तो मतलब हमारे पास एक तो आउटसाइड से लाइट आ रही है कमरे में, और हमें कमरे के अंदर 350 की ज़रूरत है. ओके, द इंडोर इल्यूमिनेशन रिक्वायरमेंट फॉर अ बिल्डिंग इज 350. सो फॉर्मूला से हम इसको अभी करेंगे. T is equal to EIEO into 100. Okay, so outside 9000 है into 100, and daylight factor is given 2.7. So EI will be 243. तो इस 9000 लक्स की वजह से आपका इनसाइड में इल्यूमिनेशन 243 ही मिल रहा है खाली फॉर्मूले से, अगर डे लाइट फैक्टर 2.7 है. ओके, और आउटसाइड में 9000 है, तो ई आई इज इक्वल टू आपका 243 है. चाहिए हमें 350. ओके, 350 इज रिक्वायर्ड. तो अब सप्लीमेंट मतलब अब आर्टिफिशियल लाइटिंग और बल्ब से कितना चाहिए होगा, तो हम इसको माइनस कर देंगे। तो रिक्वायर्ड हो जाएगा आपका, रिक्वायर्ड सप्लीमेंट्री बोलेंगे इसको, सप्लीमेंट्री आर्टिफिशियल लाइट, आर्टिफिशियल लाइट कितना हो जाएगा, 350 माइनस 243, 350 माइनस 243 इज इक्वल टू 107 लक्स, 107 लक्स। तो ये क्वेश्चन इस तरीके से करना है। नेक्स्ट एक क्वेश्चन था गेट 2016, ओके। A lamp source of 3200 candela is mounted on a wall at a height of 2 meter from the work plane. It subtends an angle of incidence of 60 degree with the center of the work plane. The illumination at the center of the work plane in lux is, lux में हमें चाहिए angle of incidence is here 60 degree with the center of the work plane. So 60 degree, because this is 90 degree, so we find 90 degree, it becomes the 30 degree. Now we have to calculate this d here. So we know the sine 30 degree is equal to perpendicular by hypotenuse d, then d is equal to sine 30 degree 1 by 2, d is equal to 4 meter. Okay, now d we have calculated. Now we require the formula illumination is equal to id square cos theta. So I here is 3200 candela divided by d square 4 into 4 into cos theta 60 degree. Angle of incidence from perpendicular to the angle. A lamp source of height and the work plane, and it subtends an angle of incidence of 60 degree. 60 degree के angle पे ये incidence हो रहा है work plane पे. This is work plane from a height. Okay, suppose ये एक table है. Then we calculate it, and this is 100 lux. Cos 60 degree की वैल्यू आप पुट करेंगे 1/2, and by solving we get the 100 lux. So of distance questions we use the inverse square law, and by inverse square law we find the illumination level. So ये वाला क्वेश्चन इस तरीके से याद रखना है. Now gate 2015. A classroom measures 10 meter into 8 meter, requires an illumination in level of 500 lux. 500 level का lux हमें चाहिए on the desk using 40 watt fluorescent lamp with rated output of 5000 lumen each. Rated output of 5000 lumen each. इसको ढंग से पढ़ो, 5000 lumen each. एक luminary से आपका 5000 flux emit होगा. Assuming utilization factor of 0.5 and maintenance factor of 0.8, the number of lamp required. So number of lamp, we know the lumen method for number of lamp. So by lumen formula we get number of lamp n is equal to E into A by F into UF into MF. So here n is equal to number of lamp, E is equal to illumination required into area by F rated output of lamp or flux, luminous flux of each lamp into UF into MF. So formula में इसको पुट करेंगे. ये हमारा यहाँ पे 500 है, into एरिया क्या निकलेगा रूम का 10 into 8. ओके, देन F इज इक्वल टू हमारा क्या है 5000 into 0.5 into 0.8 हमारा मेंटेनेंस एंड utilization factor or light loss factor, maintenance factor. Then by calculating this, 8 divided by 0.5 divided by 0.8, 20 lamps. So now we will calculate this number of lamps. If number of lamp is asked, then we use this formula. If illumination required is asked, then we change the formula and it becomes E is equal to N into F into UF into MF divided by area. So E is equal to N, and so we change this formula. So this was the question of acoustic and lighting, and some questions from GATE 2015, 16, 17, 18 and 20 we already done. So now quickly we will do the ventilation rate, conduction, convections formula, and then we will do the numerical based on ventilations and air conditionings numericals, and this we will do in another video. Thank you.